All right, this will be the last video of, I don't know what this is called, graphing rational equations. So we're on number 7, right? Yep, there it is. All right, starting off, we need to look at its domain. Actually, we'll factor x plus 1 and 3, x plus 3. Now, this is one of those that you don't really have to factor, but it is good too. I still suggest that you do this. So domain. All reals given that x won't be -3, right? Because that would make the bottom 0. We have no holes because nothing cancels. We have vertical asymptote at x is -3. We have an end asymptote at y is 1/3, right? We take those coefficients from the original. So there's a 1 and then a 3 on bottom. An x-intercept at x is -1. Plotting these, we have a vertical asymptote at -3, an end asymptote at 1/3, and an x-intercept at -1. So let's do a t-chart. We need two numbers to the left of our asymptote and two numbers to the right of it. So to the left, I'll say -5 and -4. To the right of it, I already have -1 listed because that's my x-intercept. So I'm just going to do -2. Whenever I plug these in, I get 2/3, 1, and -1/3. So putting these on the graph, -5 2/3 is somewhere around here, -4 1 is somewhere around there, and this will do a swoop like that. -2 at -1/3 is somewhere like that, and this one too will do a little swoop. And there we are. Number 8, again we want to factor. We're going to have x minus 2, x plus 3. I'm going to go ahead and cancel, and this would cancel to be x minus 2 over x plus 3. My domain will be all reals, given that x cannot be -3 or 0. I have a hole at 0. I have a vertical asymptote at x to -3. I have an end asymptote at y equals 1. And again, the way that I get that is I look at my original, I look at my highest degree terms. They're equal, right? They're both x squared. So I do a fraction of their coefficients, right? And they both have a 1 as their coefficient. Lastly, my x-intercept is x equals 2. Or x is at 2, however we want to write that. Vertical asymptote at -3, so I can do a little dotted line like that. End asymptote at 1, so we'll do a dotted line like that. X-intercept at 2. And now we are ready for our t-chart. Remember, we always have to use the hole, whatever's listed as our hole, so we're going to have to use 0. And including 0, we will have 2 points to the right of that asymptote, so now we need 2 points to the left. We'll do -5 and -4. Whenever I plug in -5, I get, I think that's a 7/6. I wrote that earlier. I know it's 1 point something. We'll say 7/6. For -4, whenever I typed that in, I got 6. And whenever I typed in 0, I got -2/3, right? -576 will be somewhere in there. -4/6 will be somewhere here. So we see that this one's going to do a swoop like that. 0, -2/3, and now I'm not going to forget this time. This is a hole, so we have to use a little circle. So we use a little circle here to signify that there's a hole. And now we can do the swoop for this side. So it should look like that. Moving on to number 9. Factoring the top, I pull out a -2, and then we'll have x squared minus 5x plus 4. And again, that will factor to be -2, x minus 4, x minus 1. The denominators, I have a difference of 2 squared, so this will be x plus 3, x minus 3. All right, and nothing will cancel, which will make a nice funky graph for us. Domain, I look at where the bottom would be 0, so all reals given that x won't be plus or minus 3. Holes, I have none because we just have none. That's like this is a circle with where it's a 0 with a little line through it signifying empty or none. Next up is asymptote, vertical asymptote. That'll be at x is positive and -3. I'm just going to write it shorthand, plus or minus. And an end asymptote, we're going to have one of those at y equals -2. Lastly, our x-intercepts, we'll have one at 4 and 1. So let's plot these things. Vertical asymptote at plus or minus 3, so we have one here and one here. End asymptote at -2. X-intercepts at 4 and 1. All right, T-chart. Starting off at the left side, I'm going to pick 2 points. We'll pick like -5 and -4. Then in the center, let's get another couple points. Let's do 0 and 2. And then on the right, we already have 1 point listed there. Let's do one more, and we'll do like number 6. Whenever I plug these in, I get -6.75, -11.4, 0.8 repeating, -0.8, and -0.7. All right, -5, -6 3/4 will be down here. -4, -11 will be somewhere in this region. So this will do a swoop like that. Now let's switch over to the far right side and deal with it. We'll have 6, -0.7, something like that. And this one's going to do a swoop like this. Okay, so which ones have I done? I've done this one, and that one. I'm left with 0.8 and 2, -0.8. Now, we should be seeing this, and we should kind of be thinking about what is that going to happen in the middle? How is that going to work? Here, let me draw what it is going to do. That's what it's going to do. And if you graph that in a grapher, it will show you this. And now this should make us uncomfortable because right here, it crosses that horizontal asymptote, right? And this is why I'm going to be calling them, or this is why I have been calling them, an end asymptote, not a horizontal asymptote, because by saying an asymptote, it makes me think it cannot cross it, right? So a horizontal asymptote, you can't cross it. But an end asymptote, it only applies to the ends, right? So this asymptote really matters over here, not so much in the middle, okay? If you're ever confused on this, just press the graph button on your calculator and then go back and see how it looks in the graph. So, but that's that. Don't be too freaked out if on the test you end up seeing one that does this. Number 10, is this the last one? Oh my goodness, it's the last one. If you're watching this in the year 2021, this is the last video, or the last video and the last problem of the last video for the year. Kind of exciting. Let's pull out our x. I'm going to pull out a -x this time. So we'll have x minus 2. Our denominator will simplify, or what is that called? factor to x plus 3, x minus 1. Domain will be all reals given that x will not be -3 or 1. I don't have any holes. I'll have a vertical asymptote at x equals -3 and at x equals 1, and I'm just going to go ahead and plug those in. Or not plug those in, I'm going to go ahead and graph them. All right, end asymptote. We're going to have one of those at y equals -1, and then my x-intercept at 0 and 2. All right, xy chart. We need 2 to the left, so I'll say -8 and -4. 2 in the middle. Actually, let's do 3 in the middle. We'll do, what do we want to do? -2 and maybe a half. And then on the right side, we'll do 3. Whenever I plugged these in, we got -1.7 repeating, -4.8, 2.6 repeating, and apparently I didn't actually type in to 1/2, so I'm sorry, we're not going to do that one. And then 3 will be at -0.25. Graphing these will be at something like that for -8. -4 will be at 4 and something, so something like that. So this one we can kind of see is going to do a swoop like this. -2 is at 2.6, right there. And we should be looking at this and saying, well, we only have one x-intercept, right? So it's probably going to do something like what we saw last time, something like that. So that's what I'm going to guess, and then we'll graph it at the very end. And 3 -1/4. So it should look like that. Let's pull up our grapher. So I'm going to type in -x² plus 2x on top, and then x² plus 2x minus 3 on bottom. And there it is. It does do a, I don't know, to me it looks like an x³ graph, but it doesn't actually follow that graph perfectly. And there we are. All right, that is the last video, and good luck on the test.